I want to win that swag bag. So, oh man, oh yeah, that would just take some time. So, I got this lot to talk to you, and then lunch is following me. So your stomachs will growl, and then that'll warn me that I've been talking too long. So, I got asked to talk about some fundamental things with Wi-Fi design. And I've been teaching wireless design for nearly 20 years now to thousands of people and have learned some things. And so I thought this time I'm going to talk a little bit about what would I tell my past self. I'm getting old, got lots of grandkids now, and thought, let's talk to the old me instead. So first, this is me. You can find me at WLAN Pros. This is my website. I'm on Twitter all the time. I believe strongly in social media, so please support there. And that's the pre-COVID hair. And then COVID came and I got white hair. I don't know what happened. I didn't know it was one of the symptoms, but it ended up being one of them. So what would I have told this old guy? This was my engagement picture. Our 40th anniversary is coming up next month, actually a month from tomorrow. And I would tell him and her, my wife, that someday we're going to have a whole bunch of grandkids. And we'll have kids, and except for what I really want to tell them is, how would you be successful in Wi-Fi? And so that's my target for today. What would you tell someone old about how to get into Wi-Fi? So some young kid wants to get in, and I'm the old guy. This is what I'm going to tell them. First, Wi-Fi is extremely complicated. Way more complicated than you think. And if you think you know how complicated it is, you're wrong, because it's more than that. Where's Peter? Is it complicated? Very. And he knows it better than most, and it's still complicated. So we can't change that fact that it's extremely complicated, because it's lots and lots of layers. From the RF layer to the actual modulation that's going on at 5 billion times a second. But it's also extremely resilient. It's crazy resilient. You do Wi-Fi wrong, you break all the rules, and it still works. The downside of that is it doesn't punish you. And I would like it if it punished you more. You would learn better. Anybody been on, I don't know, Spiceworks? Yeah, don't. They don't know Wi-Fi. But they post on there, or Ubiquity or Microtik or Netgear forums, people do something totally wrong, absolutely the worst thing you can do. And they post, yeah, I did this and it worked, see? And my answer is, yes, it worked because of Wi-Fi's resilience, not because you did it right. Just because it works doesn't mean it works, okay? So how can I explain this complexity? So I figure I'm going to use Lego, because, hey, we all love Lego, right? And so let's talk about Lego for a minute. Oh, back up one. We have a pile of Lego here. Wi-Fi is about lots of little things. You can look at Wi-Fi from the AP point of view, from the client point of view, from the traffic point of view, from the packet analysis, from what it looks like on the VLAN side. There's a lot of information, and as you go learn Wi-Fi, it feels all jumbled. But if you take that same information and you categorize it, my little clicker here is having a delay, and you categorize it and say, oh, I understand the antenna parts, and I understand the client talking part, and I understand that, and you organize it by different types of information. Maybe you take a CWNA class or an ECSE class or Peter's fantastic MIST class. There's lots of places you can go to take all of that disparate information and make it feel a little organized. You could also take that same organization and then yourself study harder. Not just organize it by clients, but then take the little details and put some structure around it. Take a bunch of notes, set yourself up a home lab and practice. So not only is it the white things versus the green things, but you know how the white things go together. But what I'd like to talk about today is, I think the best way to talk about Wi-Fi is when you put it all together, you get a story. You have a story to talk about. So I'm going to talk about today about stories around Wi-Fi. Because once you see the big picture, you go, oh, that's what that's for. Why did we have that high gain antenna that we put over there? Well, by itself, it's hard to understand. But when you put the whole thing together in a big picture, you go, oh, it's supposed to be that way because that's supporting this, which is supporting that. So first thing I would tell that younger me was you need to know yourself. And of course, I just said we're going to talk about stories, so let's talk about stories. When I was an undergrad at university, I happened to work for the dean's office. In the school of management, I worked for the dean, and this was a long time ago, so it was tech support. We had daisy wheel printers, and I had to put them in these big soundproof cages and set up computers for people. And one day, I happened to get a job interview that I had to fly off to at Boeing. And I go up to the dean, ask for a couple of days off, and he goes, you have a job interview? And I said, yeah, it's great. And I'm going there, and he reaches into his wallet, and he pulls out a folded $100 bill. And he hands it to me. And at the time, I wasn't making really great money. I was undergrad, had a wife and a kid, and that was a lot of money. And he hands it to me and said, put it in your pocket. So I'm like, okay. He goes, no, don't put it in your pocket, put it in your wallet. So I grab the wallet and I pull it out, and I've got this beam on me like, I just made $100. I was so happy. And he looks at me and says, no, you have to give it back. But I want you to have the feeling that you have $100 in your pocket. So when you go to your interview, and at the end of the interview, they leave you someplace, you have to catch a cab back to the airport, you have enough money. Or if you go out after your interview and you go to dinner, and everyone paying, and you're like, I ordered a water and some ketchup and made soup because I didn't have any money. You'll have some money. I'm like, oh, okay. So I went on my interview. Luckily, didn't have to use the $100, and told myself that was a good thing. I learned from something this dean told me. Maybe I should follow that. And today I still have $100 in my pocket. Now, I've had to use it many times, but that it's there is the important part is you put it back. And then it makes you feel different. When you go into a situation, be confident, and you can be confident if you're prepared. So that was the first lesson. The second, at the end of my final year, I go in to give some final report to him, and he says, you have 3 days left before you're going to leave this institution of higher ed, and I want you to take out a 3x5 card. And he says, you have one, don't you? And I'm like, yeah, like I carry them everywhere. He goes, yeah, and he reaches into his pocket, and he pulls out a 3x5 card. He hands it to me. Obviously, I learned from that one too. I keep them with me all the time. And he says, I would like you to write down on that card what you learned in the last 4 years. Like, I've been here 4 years. I've taken, 100 classes. You want me to put it on a card? He goes, yeah, because one of the benefits of being in higher ed, we teach lots of little things, but it's really the underlying concept. And if you can't crystallize and take and distill down, last night a bunch of you were out drinking, so I'm thinking distillation. And so I looked up last night to get one liter of whiskey, you need 10 kilos of grain. That's distillation. And then you drink it, and then you pee it out. So you want to take big pieces of information and be able to put them down into smaller pieces. And actually, I ended up getting my entire college degree, everything I learned in 4 years, on one side of a 3x5 card. So learn how to distill information down. And when it comes to Wi-Fi, yes, it's extremely complex. But find the little keys that make sense. Like really simple things. Like the last speakers just mentioned. Don't put APs in hallways. If you put an AP in a hallway, will it work? Sure. Is there a better way? Yes. So there's a rule about that. Now, when we get to rules, you also can learn to break them. So a couple of little stories just to get started about learning and knowing yourself. So for you, how do you learn? Some people learn kinesthetically, so they have to move. One of my partners in a business had before his daughter learned math by dancing. And I've seen her do it, and I don't want to embarrass myself, but she would hop to do multiplication and kind of slide. Anyway, I don't learn that way. That's not how I learn. But some people learn by listening. My wife, I don't know if any of your wives are this way, everything comes through her ears. That's how her body, it goes through her ears to get into her brain. Me, I'm the opposite. I'm a visual learner. If she texts me something, I'm at the store, she goes, can you get me this? If she calls me and tells me, I come home with 3 things that she didn't even ask for. Because if it goes in my ear, it disappears. If it goes in my eyes, it sticks. So how do you learn? It's kind of important. How many of you here are red? Ooh, we got a couple reds. How many are green? These are the note takers. They learn best by taking notes. How many are blue? You're a woman? No, sorry. How many are purple? Yeah. Having taught thousands of people in our industry, we're visual learners. So I'm going to be giving you lots of pictures today. That's what I'm here for. So I'm going to show you a picture. I'm not going to describe how all the pictures work. The distillation with the little 3x5 card, you should be able to look at the picture and describe it to a 6-year-old. Even though it's incredibly complex, if you can't describe it to a 6-year-old, you don't understand it, which means you should study a little harder. You're a visual guy, so we're going to start with the visual parts. So, again, on knowing yourself, where do you work? How many people work for a customer in pink? Because customers still need Wi-Fi. Now, the problem in our industry, if you're very focused at Wi-Fi, is it usually has to be a pretty big customer to justify having a full-time Wi-Fi only person. So there are a lot of customers, but in here we didn't have many. How many of you work for a reseller? Blue. A little more. How about a vendor in green? And consultancy. Oh, wow. Way more than I thought. So, depending on the different job you have and who you work for, you have different ways of getting compensated. Different goals. If you're in sales, you're a sales engineer, you might be more S than E. Or hopefully you're more E's than S, because I like the E's better than S's. But depending on what your role is, you have different targets and goals. A couple of years ago, I ran some surveys out to thousands of people in our industry, and we came up with a blank, an analysis of the money they got compensated for their job. Now, this is years old, but it's decent. It was thousands of people, so statistically it's pretty strong. But depending on your country, you get a huge difference. This is useful information when it comes time to renegotiating your contract, it might be nice. But what it doesn't say is I'm over here in Europe and I'm only making $75,000, I want to make $120,000, I should just move to the US. Problem is, it doesn't work that way. It's not, this shows a high amount of correlation, but not a lot of causation. It's not because they lived in America, it's just that people who live in America make more money than people who live in Europe. Moving there is not going to change that. There's another data point that's really kind of telling. We didn't expect it. We ran the survey to thousands of people. They all answered. We asked some kind of silly questions that we didn't know if it was going to matter or not. One of them was, how many nights per month do you sleep in a hotel? For work, not for taking vacations. And the correlation was extremely strong. For every night you sleep in a hotel per month, you make 4% more money. So if you're 10 nights a month in a hotel, that's 50% travel, you make 40% more money. That's a huge difference. Now, what we didn't do when we showed these big things is, the guys who are getting the 120 average, how many nights are they sleeping in a hotel? So it's not just who you work for or where you live, but it also comes down to, you just can't go sleep in a hotel every night and expect to get paid more money. The cat did not cause that to happen. But there's high correlation because it looks that way. So in your own career, don't focus on the things you think are going to do it. Just be the cat. Go to where it's going to be good. Okay, so let's move on. Let's talk about priorities. Again, talking back to my younger self. My grandfather was a mechanic, and he could fix just about anything, and he did. He worked on cars, on trucks, on caterpillars, on planes, on crop dusters. He did everything, but he did it all by feel. He would touch things and bang on them, and he kind of understood how they worked, and he would take parts off and put parts on. And he was working on this one big caterpillar once that had to be fixed. And so the company sent out some college boy from the factory to come help him fix it. And he's watching him, and he's doing this thing, and he listens to it, and he just tells my grandfather, I just replaced this little thing there. He goes, that part's not broken. And just do what I say. And he's like, how? And I was actually there when he came home to discuss it. And he's so mad because this stupid college boy, he doesn't even have dirt in his fingernails, so he's telling me how to fix this thing. And I just went, did it work? Well, yes, of course it worked. But the problem is, in our industry, many of you, and I was guilty of this myself at years ago, we focus on the what to type, where to click, what are we going to do inside the interface? And we miss the real reason we need to be focusing more on the why. Why is it doing that? How is it doing that? Let's understand a little broader. So an example, I got 3 WISP examples, and these all happened last week. I was doing some consulting with some WISPs, wireless internet providers. And the first one was this cannabis cameras. In California, marijuana is legal, and not just for medical, but just legal. It's still against federal law, so there's things you can't do, but people grow it all the time. But it's a highly valued crop, and so people who have set up these up in the redwood area, it's got good moisture, and the rain is just right to grow weed. So they have these huge weed farms, and what they want is cameras, because to get legal, you have to have security and prove that you're not allowing people just to come in, and you also don't want them to steal your weed. So this guy had set up a bunch of cameras. He was a CCTV kind of guy, and he used wireless, and it wasn't working. And he couldn't figure out why. So he calls me up, gives me the explanation, and I answer his question in 30 seconds. He's like, how did you know exactly? I mean, I just said, this is what you're going to see, and this is the results, and I know why. Off of one diagram. He's like, you nailed it perfectly. How did you do that? You're not even on site. And I try to tell him why. And I start to explain, and he jumps ahead and goes, oh, so I should go to this in the controller. No, you should understand why. And I say one more sentence, and he goes, oh, so I need to change my power level. No. Oh, should I move it? And whatever I said, he jumped right to what he was going to do to fix the problem. In the end, I said, you're not going to fix the problem until you stop doing and think through your problem, and then you can find the solution. Solutions happen that way. The next one up, another WISP who had a lot of money, huge VCs behind them, and they were going to take this WISP to the world. They put in their marketing literature, and this is a technical issue. In the US, we have something called the FTC, the Federal Trade Commission. You can't lie in ads. And they said in their ads, faster internet than our competition. Sounds good. They got a lot of people come in. And then they turned it on. And then in order to prove that they lied, all you had to do is get a competition that was faster, and then they're lying and you get your money back. So all of a sudden, all their installs are complaining because they said, we give you 100 meg down, and if you didn't get 100 meg down, then they lied. Instead of saying up to 100 meg, they said 100 meg. So, and they told me, but the literature for this access point that we're doing says up to 600 meg. I said, yeah. And so they went, well, we only needed to get 100 meg out. So that gave us a lot of headroom. And it's like 100 meg TCP is 200 airtime, and the AP can only do 600 if you have a 4-stream client. You'll never get it. And they're like, what do you mean we'll never get it? And it's like, I can prove it. One client, one AP is the fastest you'll ever make Wi-Fi go. Let's test them. So we did, and they weren't even close. They went, well, how are you're going to go out of business is what you're going to do. They did not appreciate that. They're like, well, how can we fix it? You can put a whole bunch of point-to-points to every single house on a different frequency, but we don't have enough RF spectrum, so yeah, you can't do it. You could buy licensed spectrum to go per house, but it's not going to work. And the last one was just the day before I came. In the US with COVID, they've got the government's trying to spread money around to help fix things. And one of them was they're giving cash to rural communities to bring them broadband. And they've obviously had a lot of fiber people influencing the lobby, because in the grant money, and they have a lot of grant money, if you bring broadband internet to the home in rural, they will pay for it. It's great. Places you never get a business to go. And it says 100 meg down, 20 meg up. With WISPs, you don't have enough spectrum to pull that off and to do it and to punch. And this was a very wooded area, and they just can't punch through. So they're like, but how do we guarantee 100 meg? You don't guarantee 100 meg when you have these issues. Spectrum. RF works the same way. So don't trust the whats, because each one of these guys asked me, what do I type in my controller to meet these requirements? And the answer is you can't. You didn't understand the why. You sold the whole business without understanding the why. So stay that way. Now, in your own life, think of your own priorities. And I had a demo here, but it'd take too long, so I just gave you a picture. If you only have so much time in your life, that's the size of the jar. If you find the important things in your life, family, watching your kids grow up, whatever you choose for your exercise, whatever you like, if you put those in first, like this one, you're able to put all the other little things in your life around and it fits. If you do all the little things first, mowing the lawn, I don't know, little things that aren't as important to you, if you put those in first, then the rocks won't fit. So put your priorities in first. For me, priorities are, and we're here for Wi-Fi, and what I would tell myself many years ago, sharpen the saw. If you've ever chopped wood, and I was a Boy Scout, we used to go chopping and we'd build pioneer towers and stuff. When you're chopping down a tree, you want your axe to be extremely sharp. So if you're going to chop for an hour, you'd want to spend at least 5 minutes sharpening it. And if it starts to get dull, you don't work very efficiently, so you have to sharpen it again. In our industry, that means take classes. I have tried for the last 20, 25 years to take a minimum of 2 weeks a year, and 2 weeks a year is tiny as a percentage of your whole year. How do you stay sharp if you only spend 3 or 4% of your time bettering your own skills? How many of you have taken, in 2021, more than a week's worth of classes? Yes, love it. That's how you stay sharp. If you didn't raise your hand, 2021 is probably the best year ever to take classes because you had a lot of time and you can take them all from home. So take as many classes as you can, but put your priorities first. So schedule your calendar, put all of your kids' things in first, put all your family trips in first, and then everything else will fit around it. I've been on the consultant side for at least 20 years and raised all my kids and never missed a single thing, because when someone called me up and said, oh yeah, can we meet on Tuesday? No, I already have an appointment that week. It was going to watch my daughter dance. I didn't have to tell anyone that. You can get around that. So let's get into the RF fun stuff. Now, each of these slides, I am not going to dwell very long, but you need to know them. We have tons of protocols. And if you look, there's little teeny text there. Sorry. But for every one of the protocols, there's lots and lots of things to do. Lots of things to learn. So I'm just going to be focusing on the Wi-Fi portion right now. Know the spectrum. Now, of this whole thing, Wi-Fi is a little teeny piece right over here. There's a lot more spectrum for us to deal with. This is the US version, but every country in the world has this same kind of spectrum thing. So we have 2.4. Lots of things going on in 2.4, from BLE to, is this getting chopped off? Oh, that's chopped off, but that's not. Good. So the Zigbee, all the 802.15s and the BLEs and the Bluetooth, they're all using, by the way, I like when I have a really small one, but on a big screen, you can actually read these numbers. Very nice, very nice. 3.5 gig for CBRS, and that works, and if you're in that space, you can play. 5 gigahertz, we live in the 5 gigahertz. There's so much going on here. There's also some new proposed stuff up here. I left in this picture this chunk. A moment of silence. We lost this entire segment. It was going to be ours, and there was a little swap, and so it's gone, and which is why we have this little gap. They're still there. We just lost legal ability to access them. I also added on this so you can see the wavelength, and then this is the free space loss for every channel at 1 meter. So you can tell the difference. We also have 6 gigahertz, both for the EU and the automatic frequency, etc. I'll give you these slides for free. You don't have to take a picture, but now if you zoom in really close on any one of these, and the reason I give them for free is because I think knowledge is like manure. Pause for a laugh. Knowledge is like manure because if you spread it around, you'll help everything grow. If you just hang on to it, you stink. So lots of information on this single slide of things you can learn. So again, we're just going to go through, there's a lot going on here. You need to know how DB math works. And I don't mean, yeah, it's the 10s and 3 things. No, you need to know it. If I say 17 dBm, what's the answer? Like, yeah, that should just be like, you can translate that faster than you can do feet to meters. Can you do feet to meters? Okay, it should be faster than that, but this should be just part of your soul. That if someone gives you a number in milliwatts, it goes to dBm in your head just instantly. If it doesn't feel instant, practice, 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 practice. It's something we live with this all the time, so just learn it. Free space path loss. Again, something that's just core to everything we're doing. When we understand how the RF works, this is how RF works, and you got to understand it. Understand that there's a difference between frequencies. And the flip side, and this actual slide goes back to the first presentation with Matt when he was lining up the people. If you're up here and you're trying to measure a wall thickness, and you have an AP, and you're only 10 centimeters away, well, let's say if you're really close, 3 centimeters, you could be holding it and breathe and move 3 centimeters. That would change 10 dB in your answer. Don't do it. Be out here where it gets to the flat, where if you move 3 or 5 or 10 centimeters, you get a portion of a dB, you'll be way more accurate. It also comes into bear on all sorts of design issues. Now I'm going to do a way out there. Ready? Question for the group. I design a system, and I have a big transmitter on Earth, and I go halfway to the moon. And halfway to the moon, the signal strength is X. What's the signal strength at the moon? Anyone? Yell it out. Sorry, embarrass you in front of everyone. No, it's X minus 6. It doesn't matter. Oh, come on, come back. Okay, it doesn't matter where you are on this thing. Double the distance, you get a quarter of the power. A quarter of the power is minus 6 dB. If it's halfway to the moon, all the way to the moon, 10 meters away, 20 meters away, it stays the same. So when we're out on the tail, we get some long things. It matters when we get to CCI. You're in the middle of a stadium and there's 60,000 people all with an iPhone. You know the iPhone can go 100 meters and still connect to another iPhone at 10 megabits? Your CCI is coming from the phones, not your APs. So, another thing with RF, understand modulation. So, here's what it looks like. It rotates around, and then because it rotates, you can now think, oh, the waves aren't actually turning, but if you can visualize this, then you can understand how modulation works. Because we have in BPSK, you have either 90 degrees or 0. And so this entire right side, anywhere you land, you get a bit. BPSK only sends 1. So as we look over here, and I'm just going to fly through these, I'm not going to explain them. For each one of the different types of modulation, there's more precision is needed in order to make it work. And because there takes more precision, we lose our robustness. And it's not linear. As in, when we went from BPSK to QPSK, we doubled the amount of bits and we lost half of our area. But as you go down further, you double your throughput, but you lost 4 times your robustness. And then when you go even further, let it finish. As you go to 16, you only get 50% more bits, but the cost was still 4x to your robustness. So as you're designing to smaller and smaller little EVMs, it's getting more and more difficult, and you pick up just a teeny little bit. Here it goes, ding, ding. We're only picking up 30% now to go to the next level. And we go to 1024 QAM, even worse. So understand how this works, because it drives everything that we're going to be doing. Ding, ding, let the animation do its little thing. But it's fun to watch, you know. So in modulation, we have BPSK, QPSK, QAM, 16 QAM, 64 QAM. They're different depending on your SNR. So in your building, who controls the S? Who controls the signal strength? How? Power, right. Who controls the N? You do. Whoever controls S controls N, because my S is your N, your S is his N, and his S is his N. And people go, yeah, it's environment. No, it's not. It's your own APs causing it. You control this. And if you don't think you control it, you just don't know. And unlike the last guys who would say something and say, well, you cannot disagree with that. That is just truth. Your power is causing co-channel interference. And you can control it by transmit power, or you can get some directional antennas to get around it. Okay, antennas. Also another important concept. We have weird things that go on with antennas. We have this idea in our head that I have a 30-degree antenna. Or last, Jerry talked about his 25-degree antenna. So to help, I made a 30-degree antenna out of paper. And if you want, it's on my website, you can download it and print your own. 4 pieces of paper, cut it out, you got it. Now, if I want to say, I'm up here and I want to cover that section, how much do I cover? And I can see it. I don't need to get any fancy tools. I just, okay, one covers to there. Oh, there's a second one. There's a third one. And you can see it. The problem is, we talk about antennas like they have this instant fall off. So if I called this one this one happens to be a 60-degree antenna, because if you go up 30 degrees and down 30 degrees, it's where it crosses the -3 line. And they call that a 60-degree antenna. Some people look at these and they think it's about distance. It has nothing to do with distance. What it has to do is if you're right here at the 0 degree, you would receive the maximum amount of energy. That's all this means. And if you went over here 30 degrees off, you would receive 3 dB less energy. Now, how far away is it? I don't know. It doesn't matter. If I'm 10 meters, it's still the same. If I'm 50 meters away, if I'm 200 meters away, if I go over to the 30-degree edge, I get 3 dB down. So how we might use this is you design a network and you say, I want to hit person right there in red. I want you to receive -60. That's my target, neg 60, good point. So I aim it and I measure, and you have neg 60. 30 degrees over, let's see how far that is. Put you on the edge. Oh, another red shirt, great. You, what do you get? Neg 63. That's beautiful. What's not so beautiful is over here at 30, 40, 50 degrees away, it's 10 dB down. 30, 40, 50 degrees. What are you getting in the blue and white shirt? Can you connect at 70? Are you getting CCI at 70? So I'd get this nice tight 30-degree antenna and go, oh, I got it. And you're over there you're in my listen zone. So you think a 30-degree antenna is this. It's really important, and Jerry brought that up. You need to see what the side lobes are. How wide does it go? So this is also cool that you flatten it, and now it's a 60-degree antenna. See? Just look through it like that. It works. Antennas matter. Antennas matter a lot, and they are not the same. This antenna up here, they all have 10 dB input, and this one has ERP of less than 10. It is a negative dB antenna. Note, I blocked off the names to protect the guilty. This antenna puts 10 in and gets nearly 19 out. It has a 9 dB gain. 0, 9. Do you think your design would be different if you chose these two different antennas? It's hugely different, and they cost the same money. Pick your antennas first. Okay, you need to understand the RF, you need to understand the phi. How do all of the things in the physical layer work? How does the contention process work, the MCS process? How much overhead is there? If you don't understand them, go learn it. There's places to learn. Contention process happens all the time. We sometimes call it the game, and we walk how each client gets the chance to talk, and they round robin through. Understanding MCS is huge. It is my #1 way of determining health of the network. A client, let's just take a client over here and client says, I can talk 2 spatial streams up to 80 megahertz wide. Hey, AP, what do you do? The AP says, I can do 4, but I'm only 2, so we negotiate down, and we can only do this 867. Does that mean I'm going to transmit at 867 all the time? It's highly dynamic. It changes as you go through the day, minute by minute, frame by frame. And by the way, every transmitter makes this decision. Receivers have nothing to do with it. It's a transmitter. So the client chooses how he's going to talk, the AP chooses it's going to talk, and they all have different algorithms. Some go up when they fail, some go over when they fail, some go stair-step. I have a client that went A66, fail, fail, fail 5 times, went right up to there. It was smart. It was a voice client, and it said, I'm probably moving on the human who's carrying me. The last association I had, I was associated to this AP. I should get this, but I didn't have any frames to send. But when the person picked up the phone to dial, I now have a frame. I'm going to try. It failed. So let's jump up here and see, am I on the right AP? Because if I can't do BPSK at 1 of 2 coding at 800 nanoseconds with 20 megahertz, I can't do Wi-Fi. So then I forced to run. So they used the MCS table to figure out when and how to roam. Yeah, when you get to AX, it gets even more complex. I was going to do this live, but we don't have time. But I have the equipment. You can set up a MCS test and watch your clients. Somehow, and I don't know where it came, people think that this is stable. I can set up a wireless bridge between 2 places, and you go, oh, if you walk in between, it's going to change. No, I can stand perfectly still and watch these, and they change all on their own. Usually because there's a load in the air that causes one of them to say, error, error, error. Oh, I got too many errors. Probably because it was too busy, and they downgrade to try to get through. And when one downgrades, it takes more time, makes the other ones downgrade, and they catch up as well. So, it's not about the green. We think we like and we understand green, but we're just talking about the RF issues at the MAC layer. Football field, we surveyed every 5 meters for the whole length of it. It's a U.S. football field, sorry. But we did everything in meters. On the left is a MIST 43. On the right, it's a Cambium. They're both Wi-Fi 6. This data came off of the same clients. And the Cambium doesn't have as good as the MIST. You would say, oh, look at that. Bad. Not good RF. And truthfully, its antenna is not nearly as good as a MIST. But it has 8 spatial streams. And we were talking, this is the aggregate of an iPhone, an iPad, a MacBook with 3 spatial streams, and a Intel chipset. And the spatial streams beat the 8 spatial streams beat the 4 spatial streams constantly. Spatial streams matter. And what if I had been cheap and put in a 2x2 AP? It would have been even further than this. So spatial streams matter, and this is just the data to support that. Wi-Fi 6, in the same testing, Wi-Fi 6 beat non-Wi-Fi 6 every time. That ThinkPad was an 8-year-old ThinkPad, but we put in a brand new Wi-Fi 6 chipset. And it outperformed every time. This is a 3x3 MacBook. That extra spatial stream should have helped, and it did, but it wasn't as good as going to the next chipset up. Even the 1x1. And look at this. 100 meters out, there's an iPhone getting better than 35 megabits throughput at 100 meters. When we tested iPhone to iPhone, we still got above 10 megabits per second, just 2 iPhones talking to each other. This is another requiem sadness. We think what we talk about in the Wi-Fi and the data rates matter. It's only the blue that matters. If you walk through all of these individual steps, are all there to carry little teeny bit of payload. The payload is a tiny little bit of what we're sending. And if you compare these, you think, oh, I'm going to go from this scenario to this scenario. We're going to go to AP, big, huge aggregates versus a smaller one. But the whole net time is very little. So as you're learning each of these things, you need to know the RF. You need to know the PHY. You need to know the MAC layer and how the whole association process works, how a client joins and then encrypts and then gets to upper layers and then can pass local traffic and then gets the captive portal. And captive portals, they have their own set. There's an entire set of things to look at there. You also need to understand the entire network that goes around it and all of the network services that go with it. So any one of these graphics I've shown up could take a half hour, an hour, 2 hours, half a day to teach you to understand. Well, this one would take weeks. All of which have to do with whether or not Wi-Fi is going to be successful. Big picture, I showed this in Birmingham a couple of years ago. It hasn't changed. You should be able to look at this graphic and follow the flow of every frame through your entire network over and over. If you don't, and you don't understand it, you'll be back going, I wonder if I just hit it this way. Should I, I'm going to go change my transmit power. Let's try that. It shouldn't be I'm just going to go whack around at things. What should I do? It's if you understand how. So, last little teeny bit here. If you haven't looked it up, look at Bloom's taxonomy. I think Bloom's is one of we've heard of Maslow's hierarchy, self-actualization at the top, needs, what was it? Battery, then Wi-Fi, and then food. This is about how to learn, and there's words. And the higher you go, the more you get paid. I would tell my old self, if you want to get paid a lot, be way up on this list. And there are words that have to do with this. If all you're getting paid to do is repeating something over and over, versus you're over here detecting and defending and commenting, and use the words to describe what you do to your boss, and you can get paid more. So, that's. So, last slide. What to do next? Engage in the community. One of my big rocks is Twitter. People go, how much time do you waste every day on Twitter? I don't waste any time on Twitter. I built an entire business off of Twitter. I have friends all around the world because of Twitter and because of Slack and because of other social media. They don't need to be a drain. Now, on the other hand, if you're looking at cat pictures, maybe it's not going to help your career any. Understand Wi-Fi, like at your core. It can't be just a little, oh yeah, I think I know that. No, you got to really, really understand it. How many of you have a home lab? Oh, let's reverse. How many of you don't have a home lab? I hereby swear I will have a home lab by the first of the year. It will change your life. Lots of places to learn. So I'll just leave this last one up. I didn't cover these. They were in a previous presentation I gave, but so you just have them there. If you're going to design wireless LANs, know it. Understand what it is. Spend time on yourself. Make sure that every time you study and take another certification and learn one more thing, you're improving your skill set. Thank you. Oh, lunchtime.